It would explode and destroy all of New York City, parts of Connecticut, and New Jersey. This is one of the greatest mysteries in our physics. Betelgeuse, a celestial wonder gracing the night sky, is an iconic red supergiant nestled in the Orion constellation, captivating stargazers for generations. Recent updates from renowned physicist Michio Kaku have raised concerns suggesting that Betelgeuse may have finally exploded. How this explosion reshapes our understanding of stellar life cycles and the forces shaping our universe is a question of great significance. What implications does it hold for us? Stay tuned to find out. Imagine gazing at the night sky and spotting a brilliant star in the Orion constellation. Betelgeuse, also known as Alpha Orionis, is a significant star in Orion at approximately 5 hours 30 minutes right ascension and 0 declination. Orion derives its name from the legendary Greek hunter in mythology, recognized for its brightness. Orion boasts numerous prominent stars, with Betelgeuse, a variable star with a distinctive reddish hue, ranking as the 11th brightest globally at a magnitude of 0.6. Notably, Betelgeuse is the brightest star in Orion, shining like a beacon on the hunter's shoulder. The name Betelgeuse originates from the Arabic word bat al-jawza, meaning the giant shoulder. In 1603, astronomer Johann Bayer bestowed the star with its special name, Alpha Orionis, signifying its status as the brightest star in the Orion constellation. Interestingly, despite Rigel now being recognized as the brightest star in Orion, Betelgeuse retains its name proudly. Betelgeuse is a colossal star with a mass about 764 times greater than our Sun, making it a giant compared to our solar system. To put it in perspective, if the Sun were a tiny marble, Betelgeuse would be a huge basketball. Determining Betelgeuse's distance has been challenging, with estimates placing it between 500 and 600 light-years away from the Sun, a vast distance in cosmology. In terms of brightness, Betelgeuse shines brightly with a superbright rating of about 6. Harvard University researcher Morgan McLeod notes that Betelgeuse's proximity and size make it one of the few stars scientists can closely examine using telescopes on Earth and in space. Telescope images reveal Betelgeuse's unique features, showcasing a surface distinct from our Sun's smooth appearance. Instead of a uniform sphere of extremely hot plasma, Betelgeuse appears as a collection of uneven boiling gas pockets, some comparable in size to small stars. Significant upwellings of hot material rise from Betelgeuse's core to the surface, resembling cosmic spring cleaning. One such shell is so massive that traveling at the speed of light would take 75 years to traverse it. This process, known as surface mass ejection, SME, expels materials from Betelgeuse's outer layers, similar to the Sun's coronal mass ejections. Despite its youth, Betelgeuse has already exhausted the hydrogen fuel in its core, entering the latter stages of its existence as it transitions into the red giant phase. During this phase, Betelgeuse utilizes helium to produce carbon through fusion processes, showcasing a rapid evolutionary journey fueled by its substantial initial mass at birth. According to scientists, Betelgeuse began its cosmic journey as a blue-white O-type star, belonging to the most massive category of hydrogen-burning main sequence stars. In the realm of stars, size directly relates to brilliance and intense heat. Larger stars like Betelgeuse shine brighter and burn hotter, but this also leads to faster hydrogen consumption and an earlier transition to the red giant phase. Betelgeuse's surface once reached staggering temperatures of up to 89,500 degrees Fahrenheit, a sharp contrast to our Sun's lukewarm 10,000 degrees Fahrenheit. As Betelgeuse consumed its hydrogen and began fusing helium, its outer layer expanded significantly, making it one of the largest stars we know, stretching over 700 million miles in diameter. Presently, Betelgeuse's surface temperature is around 5,800 degrees Fahrenheit, cooler than the Sun, yet it outshines the Sun by an impressive 7,500 to 14,000 times. In 1836, astronomer John Herschel observed fluctuations in Betelgeuse's brightness, leading to its classification as a semi-regular variable star with periodic changes and occasional irregular fluctuations, typically following a 400-day cycle and approximately a 5-year cycle. Betelgeuse exhibited an anomaly in 2019, deviating from its usual behavior. Its erratic conduct gained attention due to unpredictable changes. Historically, its luminosity oscillated following a consistent 400-day pattern, brightening to a magnitude of 0.3 and then dimming to around 0.8. These fluctuations were associated with the outer layer called the photosphere, which emits most of the star's light and heat. Convective motion in the photosphere, where heat moves from the interior to the surface through gases, causes variations in brightness over time. During the autumn of 2019, Betelgeuse experienced the Great Dimming by approximately 60%, marking a deviation from its usual pattern. The cause was a massive ejection of material forming an extensive dust cloud obscuring our direct view. Although the dust cloud has dispersed, Betelgeuse hasn't fully returned to its previous state, and its 400-day brightness cycle has shortened to just 200 days. Betelgeuse's unpredictable behavior sparked discussions about the potential for an imminent supernova explosion. In a supernova, as the star consumes its remaining fuel, its core collapses, giving rise to a black hole while expelling outer layers at speeds up to 25,000 meters per second. If Betelgeuse undergoes a supernova explosion, it would be a breathtaking display visible for several weeks, similar to the full moon. Due to its proximity of just 650 light-years, while star explosions are common, they're often too distant to be seen without powerful telescopes, making Betelgeuse's potential supernova a remarkable event for night sky observers. As stars evolve, their cores accumulate iron, eventually triggering a supernova. The most recent observable supernova, SN 1987A, occurred in 1987, approximately 168,000 light-years away. This event, visible to the naked eye, provided valuable insights into stellar evolution. The last recorded supernova before that, documented by Johannes Kepler in 1604, outshone all other stars in the sky even during the day, but had no significant effects on Earth due to its considerable distance. Betelgeuse, a star in the spotlight, is expected to undergo a supernova. Miguel Monters, a Betelgeuse expert, anticipates its brilliance to rival that of the full moon when the supernova moment arrives. Picture a mesmerizing 2-month span where, on a clear night in an unlit city, you could read a book bathed in the glow of Betelgeuse's supernova. In 2021, Betelgeuse experienced a dimming event similar to the 2019 phenomenon, with around a 60% decrease in brightness attributed to the presence of a cloud within the star's wind. The cloud concealed half of the star, causing a missing southern hemisphere in images. Following this dimming event, Betelgeuse abruptly increased in brightness by 50%. The cause of this surge remains unknown, leading to speculation among astronomers. Betelgeuse, currently 15 to 20 times the size of the Sun, falls into the category of stars predicted to undergo a supernova, signaled by its red hue as a red supergiant. While astronomers generally propose that Betelgeuse could supernova within the next 100,000 years, a recent study by Hayuki Seo and colleagues from Tohoku University suggests it might be in a more advanced stage, closer to exploding. However, there are differing opinions on the validity of this conclusion. Seo's team bases their assertion on Betelgeuse's pulsating behavior, regularly expanding and contracting with overlapping overtones. Although they don't predict an imminent explosion, they suggest it could happen within the next 1,000 years, challenging the longer timescales previously considered. The uncertainty surrounding Betelgeuse's timeline has become a focal point for astronomers as they try to predict the star's future. Many scientists are particularly fascinated by how long it will take for Betelgeuse to end its life in a spectacular supernova. While some predictions suggest it could explode within the next 100,000 years, there is still much debate about this time frame. Stars of Betelgeuse's size and mass typically burn through their fuel quickly on a cosmic scale, but even quickly in this context could mean millions of years. Some scientists argue that massive stars like Betelgeuse can endure for more than 10 million years before collapsing. While 10 million years might seem like an impossibly long time for most people, it's a relatively short period in the grand scheme of the universe's 13.8 billion year history. For astronomers accustomed to studying objects that have existed for billions of years, 10 million years is considered a rapid life cycle. The mystery surrounding when exactly Betelgeuse will explode has spurred astronomers to search for clues, particularly by closely observing the star's appearance. One of the most promising signs that Betelgeuse may be nearing its final stages is a potential change in its color. The color of a star provides essential information about its temperature, age, and what stage of its life it is in. Red supergiants like Betelgeuse are in a late evolutionary phase, having already burned through the hydrogen in their cores and now fusing helium and heavier elements. As a star nears the end of its life, the changes in its internal processes can sometimes alter its outer appearance, including its color. Intriguingly, there are ancient writings that describe Betelgeuse's color as being more yellowish, similar to Saturn, rather than the deep reddish hue we associate with it today. For example, early Chinese, Roman, and Arabic astronomers wrote about Betelgeuse as being yellow or orange, which contrasts with modern observations that identify it as distinctly red. This historical discrepancy has led scientists to ask whether Betelgeuse has actually changed color over time. If it has, this could suggest that the star has evolved more rapidly than expected. A shift in color from yellow to red could indicate that Betelgeuse has moved from an earlier phase in its life cycle to its current status as a red supergiant, and that it may be closer to going supernova than we initially thought. The possibility that Betelgeuse has undergone such a rapid evolution raises important questions about how stars age and die. If the star's color change is real, it could serve as a valuable clue, helping scientists to better understand the timeline for when it might explode. Astronomers rely on observations like these to piece together the final stages of massive stars' lives, using color shifts as a diagnostic tool to gauge where a star is in its evolutionary process. Despite all the uncertainty, one thing is clear. When Betelgeuse finally does explode, it will be one of the most extraordinary astronomical events ever witnessed by humanity. The star's proximity to Earth means that the supernova would be visible with the naked eye, likely as bright as a full moon. The explosion would illuminate the night sky for weeks, offering a once-in-a-lifetime celestial spectacle. Whether Betelgeuse explodes on schedule within the next few thousand years, or whether it takes its time and drags out its final phase for another 100,000 years, humanity is poised to witness the dramatic conclusion to one of the universe's most inspiring phenomena. It would be a breathtaking testament to the diversity and power of the cosmos, and an opportunity for scientists and casual stargazers alike to marvel at the incredible forces that shape the universe. If Betelgeuse were to go supernova, it would be one of the most dramatic cosmic events visible from Earth in recorded history. The explosion of a star as massive as Betelgeuse would send shockwaves through both the scientific community and the general public, sparking awe and wonder as people around the globe witness a spectacular transformation in the night sky. The idea of a supernova, a powerful stellar explosion captivating our skies, has long fired the imagination of astronomers and stargazers alike. Supernova simulations have been instrumental in helping scientists understand what such an event would look like from Earth. Based on these models, when Betelgeuse explodes, it is expected to shine with a brightness comparable to the full moon or perhaps even brighter, creating a second sun-like object in the night sky. Because Betelgeuse is relatively close to Earth, at about 500 to 650 light-years away, the explosion would be clearly visible to the naked eye. This supernova would be one of the rare stellar events that humans could witness without the aid of telescopes or other observational tools. For weeks, perhaps even months, the night sky would be dominated by the brilliant glow of the exploding star, outshining every other celestial object besides the actual sun. The explosion would be so bright that it would be visible not only at night but also during daylight hours for several weeks. Betelgeuse's supernova would rival the full moon in brightness, casting shadows and illuminating the Earth in a soft glow. This display would persist for some time before gradually fading over the course of months to a year. Eventually, after the initial brilliance dims, the remnants of Betelgeuse would be visible as a faint ghostly nebula, a beautiful and lasting memorial to the star's explosive death. Despite its breathtaking visual display, Betelgeuse's supernova would pose no significant threat to life on Earth. Recent research suggests that a star must be within about 150 light-years of Earth to have a noticeable impact on our planet's environment. Betelgeuse, sitting at approximately 500 to 650 light-years away, is well outside this danger zone. This means that while the explosion would be a spectacular sight, it would not endanger life on Earth in any meaningful way. In contrast, historical evidence suggests that supernovae closer to Earth may have had more profound effects. For example, about 26 million years ago, A supernova is believed to have contributed to an extinction event during the late Pliocene era, impacting marine life. The high-energy cosmic rays from that explosion may have caused disruptions in Earth's atmosphere, possibly leading to changes in climate or other environmental factors that played a role in the extinction of species. In the case of Betelgeuse, however, no such threat exists. Although the supernova would release a large amount of energy, including cosmic rays and ultraviolet radiation, the star's distance from Earth would prevent any severe harm. At most, the explosion could cause a temporary depletion of the ozone layer, but this effect would be short-lived and minor, with no lasting damage to the environment or human health.